All right, so here we go. We're going to do double angles. So we just finished doing the adding and subtracting, the sum and difference formulas. Now we're going to look at double angle formulas. So, the big idea that you're getting here is that you don't have just an angle here. You have a number with the angle. Or with the sum and difference, you have two angles added together, but it's not just the angle, and that's what we don't like. We want just the angle. We don't ever want a number here. We don't ever want two things being added or subtracting. So when you have a number here, you're going to use a formula to get rid of it, basically, to replace it. You're going to replace this with something else so that there's not a number there. So let's just look at where we get a double angle formula from. So if you think about it, 2 theta is the same thing as saying sine of theta plus theta, right? Because you have two of them. And so then now if you have two of them, you use the sum formula that says you take the sine of the first one times the cosine of the second one plus the cosine of the second one times the sine of the first one. Well, if you look at this, this is exactly the same thing as this. So since I have two of them, I'm going to rewrite it as 2 sine theta cosine theta. And that is actually the double angle formula. If you look at your formula sheet, the double angle formula says sine of 2 theta equals 2 sine theta cosine theta. The theta being that angle right there, then goes there and there. And notice in my final, I just have theta. I don't have a number here or here. I can have a number in front, but I don't have a number with the angle, and that's the big deal. So let's look at an example of what you would do. So here, you're supposed to find sine of 2 theta, cosine 2 theta, and tangent of 2 theta when you know what cosine of theta is. Now it's telling you theta is between 3 pi over 2 and 2 pi, which means theta is in the fourth quadrant. So this is where theta is. Now remember, we're finding sine of 2 theta. This is where theta is. 2 theta is somewhere else. But we don't know where. We're not told enough about theta to know where it is. All we know is where theta is. So what that means is if I want to find the sine of 2 theta, I can't do it right now because I only know what I know about theta. And what do I know about theta? I know the cosine is 5/13. So adjacent over hypotenuse is 5/13. So then we use the Pythagorean theorem and we find the third side and we get -12. And we know it's negative only because we're in the fourth quadrant and this side right here is negative. Okay. So how does that help us? Well, the formula for sine of 2 theta is 2 sine theta cosine theta. And what's nice about that is now with my formula, I now have just a theta, which means I can use this triangle. See, before I had 2 theta, I couldn't use this triangle. And I know some people are like, well, let me just take it times 2, take my answer, opposite over hypotenuse, and take it times 2. But that's not how this works. This is saying a whole different angle. I mean, imagine if this was 30 degrees, then I'm finding the sine of, really, technically, I'm finding the sine of 60 degrees, right? And I can't take the sine of 30 degrees. Sine of 30 degrees is, what, 1/2? If I took that times 2, I would get 1. But is the sine of 60 degrees 1? It's not. It's √3/2. So it doesn't work that way. You can't just take it times 2. You have to use a formula. So we're using the formula here. We've got 2, and then we have the sine of theta, which is -12/13. And we have the cosine of theta, which is adjacent over hypotenuse, 5/13. Let me make this a fraction just so I have all fractions. Go ahead and multiply. We're going to multiply across the top. We get -120. Multiply across the bottom. We get 169. So that's the sine of 2 theta. Then we have to find the cosine of 2 theta. So notice we have 3 formulas for the cosine 2 theta. Some are easier to use for different situations, and that's why you have 3 of them. So I think I'm just going to use one of them. Well, I know I'm going to just use one of them, but I think the one I'm going to use is the one with cosine in it, and just cosine. And there's a reason why I picked that one. And that reason is because, remember how we've always talked, use the original information as much as possible. We were told what cosine is. What if this really isn't -12? What if we made a mistake? I don't want to use this number then. So I'm using the original information, and since the second formula has just a cosine in it, that's what I'm going to use. So then we go ahead and plug in 2. Now cosine is 5 over 13, and it says that's squared, so I'll square that minus 1. And then we do our math. 2 times, well, if I square top and bottom, I get 25 over 169 minus 1. This is 2 over 1, so I get 50 over 169 minus 1. 1 is going to be a fraction of 169 over 169. And so I get the cosine of 2 theta then is, if I take and subtract that, negative 119 over 169. All right, so there's cosine. And then we have to find tangent. Now, let me tell you a little secret. You know how tangent is sine over cosine? So tangent is sine of 2 theta over cosine 2 theta. And then I like to go, well, here's sine of 2 theta, negative 120 over 169, over, where's cosine? Here's cosine, negative 119 over 169. The denominators cancel, the negatives cancel, so I get 120 over 119. And so there's tangent. So if you know sine of 2 theta and you know cosine of 2 theta, you can find tangent of 2 theta by dividing the two. However, of course, that's not what's intended. Intended is to use the formula that they give you. And so that formula is tangent of 2 theta equals 2 tangent of theta over 1 minus tangent squared theta. And so I need to plug in for that. Now, if you remember, my triangle goes like this. It's negative 12, here's 13, and here's 5. So tangent is opposite over adjacent, so negative 12 over 5. And then 1 minus tangent is negative 12 over 5, and we got to square that because it's tangent squared. So it's 2 over 1, so we get negative 24 over 5 divided by, and then on bottom, let me just do some of this math. We've got 1 minus, square that, we get 144 over 25. I have to get a common denominator so I can subtract. And let's see, negative 25 minus 144 gives me negative 119 over 25. And so that's what I get on the bottom. So I'll put that here, 119 over 25. And you'll notice I can't cancel denominators this time. So then I have to actually go ahead and multiply by the reciprocal. So I multiply by 25 over negative 119. The negatives are going to cancel. 5 goes into 25 5 times. And 24 times 5 is 120 over 119. And you should recognize that as what we got before. Okay, so wasn't that fun? Isn't that the way you want to do it instead of the way I did it on the other page? No, not really, right? So here's what I'm telling you. I will allow you to use the other one, but what if you're not told sine and cosine? What if you don't have that information, is all you're asked for is this? Then you have to be able to do this. So this is a good thing to practice, and I really highly recommend that, is practicing this. But that is it for double angle. Not it, but that's it for finding the angles of double angle. You're going to have another video on solving. So here we go. Good luck.